up, guys? Welcome back. Today we're gonna be doing Unit 1 review. As you can see, we got some spicy questions here. So Lesson 1 all the way to Lesson 7. Without much saying, let's go ahead and get started. I will be covering all of these questions, so I will not only be doing the odd ones, I'll be doing all of them. Okay. Wow. Okay. Let's go ahead and do question 1. Our text is a little bit too big, which I don't want it. So Unit 1, we're going to start up simple. Determine whether each relation is a function and determine its its domain and range. So let's go ahead and get started on this. So 1, obviously that's a cubic function, so for sure, function. And then for a cubic function, we know the domain and we can see the arrows. It stretches all the way. So that means x is all real numbers. And for range, it's the same. We can see that this arrow goes all the way down and this arrow goes all the way up. So range is y is all real numbers. And for 2, this deserves a little bit of work, and hopefully you got warmed up by the first question. So 2 right here, they gave us a question, a function, an equation for us to work with. So 3x squared plus 2y equals 6. Whenever we have something like this and we want to determine if it's a function or not, we want to go ahead and isolate for y. So 2y is equal to 6 minus 3x squared. Y is equal to 3 minus 3 over 2x squared. So we want to notice that this is a cubic function. Sorry, this is a quadratic function. So for sure, definitely it is a function. So function. And now the domain for for quadratic functions is pretty easy as far as we're concerned. X is all real numbers. And that is the domain for every single quadratic function that you get. X is always all real numbers. However, the confusing part is the range. How can we find the range? Well, notice that there is no horizontal translation, and the only shift to this entire function is a vertical shift of +3. That means our quadratic function is still right on top of the y-axis, meaning that if we set x equal to 0, we will get our y-intercept, which is also our maximum. Let's go ahead and do that. So if we set x equal to 0 and we find the maximum, then our maximum is at 0, 3. So one thing that we know about quadratic function is that if the positivity, the concavity depends on the positivity of the leading coefficient of the x squared. So for example, we have negative 3 over 2. So it is negative, meaning our quadratic is concave down and opens downwards. That means our y values will be a list of values below the maximum. So we will have, let's just talk about it. So maximum at 0, 3. And because our parabola is concave down meaning you have a U shape like this, it faces downwards, we will have all y values below the maximum. This includes the maximum. This means range for us is y is all real numbers such that y is less or equal to 3. And that is our range. Let's go ahead and talk about question C. Right away we see, this is C. That looks like a reflected sort of a sinusoidal function, a trig function, but instead of on the x-axis, on the y-axis. And right away we see it doesn't pass the vertical line test, so this is not a function, rather it is a relation. However, we can still talk about the domain and range of a relation. That doesn't really stop us. Let's talk about the domain. So we see that this is the periodic function. It kind of goes back and forth. So for the x value, the lowest it could go is -1, and the highest it could go is 1. So let's go ahead and write out the domain. And then we see that there is an x value on top of -1. There's also a value on top of 1. So this means that x is all real numbers, but such that 1 is less or such that -1 is less or equal to x is less or equal to 1. So we will have -1 x. This is our domain. Let's talk about the range, because our range is something interesting here. This range, we're not quite sure about what we're gonna do with the range, because as far as we can see, this range seems to go all the way up. So that's correct. It does go all the way up. So this means our range is y is all real numbers. Y is all real numbers. Any value, any value of y, there will be there. It will be there. It's going to be there. Okay, let's go ahead and get to our very last part, D. Add 6 equal to 2 to the power of y. So we can rewrite this in terms of y. And how do we do that? We use something that we did in grade 11, which is logs. If we log both sides, the exponent will come down to the bottom. So let's log both sides. So log x is equal to, the exponent comes down to the bottom, so y log 2. So y is equal to log x over log 2, right? But now, when we have this, we can use our change of base formula. So log x over log 2, that's just basically y equals to log x to the base of 2. To the base of 2 instead of 2. Okay, so okay, I can't really do it here. So log x to the base of 2. And now this is a function because this is a logarithmic function. For every one value, there's exactly one y value for every x value, so it is a function. So function. Now, important part is the domain of the logarithmic function. So the logarithmic function has a domain of everything, and because we don't have any translations, of course, so domain, we will have every value that is greater than x. So x is all real numbers such that x is greater than 0. Is greater than 0. Because x cannot equal to 0. When we put x into this function, log x, what is that? It's not really defined, isn't it? Right? So it cannot be x. Right? Log 0 is undefined because we have that asymptote. So it cannot be 0. So x is greater than 0. And we're going to look into logarithmic functions much deeper soon. And the range, however, from the bottom, it goes like this. This is how a log looks like. Right? It goes from the bottom all the way to the top. Even though on the right, it looks like it's increasing very slowly, it's still increasing. So range is that y is all real numbers. Okay, let's go ahead and move on to number 2. A cell phone company charges a monthly fee of $30 plus $0.2 per minute of call time. Write the monthly cost function, C of t, where t is the amount of time in minutes of call time during a month. So we'll have a monthly fee of 30. So that is constant. It will always have 30. So let's go ahead and write this out. So monthly fee is $30. Always there. And we'll have per minute charging of 0.2 cents. Or just 2 cents. Right? So what's the monthly cost function? And we're using t. So cost function is C of t. We'll always have $30. So 30 plus t is in the amount of time in minutes, right? So 0.02 t. Okay, sounds straightforward. But now let's go ahead and talk about the domain. So what is our possible values? So domain right here, instead of being x, we're going to look at t. What values can t be, right? So right away, time cannot be negative. So we can't have like negative minutes. So t has to be greater or equal to 0. So domain, t is all real numbers such that t is greater or equal to 0. Because it makes sense if we don't have any call time, right? It makes sense. That works. It just doesn't make sense if we have 0. If we have negative. And the range of c. So we can see, since we already restricted our domain, our range is going to be correlated with our domain because we have an application question. So let's see. At t equals to 0, we will have flat out $30. But we can't really have anything less than $30, right? Because t is never going to be negative. So we will never have a cost that's less than $30. So range is C of t is all real numbers such that wow such that C of t is greater or equal to 30. They are greatly correlated. Okay, and we're done. Question 1.1. Let's go ahead and get into 1.2. So we're gonna graph this function, which I will be skipping, but it's very simple. You guys should be able to do it really quick. It's an absolute value function, so we all know how an absolute value function goes. I'll just quickly give you some information. So, let's go ahead and name our parent function, which is the absolute value of x, right? So, when we have this parent function, let's talk about the transformation that we have. So, we will have, first of all, we'll have a vertical stretch by a factor of 2. Stretch by a factor of 2, right? Because we have this 2 here, and then plus 3 within the bracket. So that means 3 units to the left, right? 3 units, horizontal shift, 3 units to the left. Horizontal shift, 3 units to the left. And then finally, we'll have that 1, negative 1, so which is negative 1 vertical shift, 1 units down. Okay. And let's go ahead and we can find out some useful points which you can do on your own, because this is definitely not a hard question. Let's go ahead and move on to number 4. Describe this interval using absolute value notation. So the graph shows we have negative 2 less than x is also less than 2. And notice that they have open dots here, so negative 2 and 2 is not included in this range. So whatever we wrote here makes sense. So we could see the endpoints are open circles and negative 2 and 2 are not included. The midpoint of this is 0, and the distance from midpoint to either endpoint is 2. So if we want to use absolute value, that means the absolute value of x is less than 2. Okay, let's go ahead and move on to unit 1.3. For each pair of functions, give a characteristic that the two functions have in common and the characteristics that distinguishes them. So right off the bat, we do have a very, very obvious and a very friendly function that we have worked a lot with. It is just f of x equals to x squared. And also we have a sinusoidal function that some of us might hate, but some of us might love. So let me just move this on the right. I'll move back later. Let's go ahead and give us another text box. Give me another text box. Fancy. Okay, this doesn't work like that, so let me just copy and paste this. Remove. Alright, let's go ahead and talk about these two functions. So, right off the bat, you could think, these are kind of weird. It doesn't seem to have anything in common. So we could talk about something like domain. So domain is a very generic thing. So obviously, right off the bat, we found one thing that they have in common. So 5a, the common thing between a quadratic function and a sine function is their domain. Now, what is their domain? Well, domain is simply x or so real numbers. Right? For every x value out there, a quadratic function is defined. There's a y value. And for every x value out there, there is a sine value for it too. But now, what are the differences? The difference is, well, let's see. Let's talk about something that is unique to a sine function. Because a sine function is very unique. It's very interesting. It's a lot different than whatever numbers we have. It's degrees, you work with radians, you work with repetitiveness. So basically, we can think about sine function is that sine function is bounded. It goes back and forth, and it's periodic, right? The difference is sine function is periodic, and when it's periodic, it limits itself. It's bounded. It has its domain bounded. So negative 1 is less or equal to sine x is less or equal to 1. The lowest point you could get on a sine graph is negative 1, and the highest point you could get is 1. Right? This is pretty obvious. So the difference is the sine function is periodic and is also bounded with its range being right here. Now let's go ahead and move on to B. Hopefully I spice things up a little bit. So we have an inverse function, or not an inverse function, sorry, a reciprocal function, and just a linear function. So in common, we can see that what do we have? So the most common thing across most of these functions is that probably domain. So what is domain? So we could see, let's talk about something. Common domain. Common domain thing is that they both include positive and negative numbers. Common domain, as it includes all positive and all negative numbers. Right? Both of them include both. But because 1 over x is such a unique function, there's so much things we could tell. There's more differences than common, obviously, for this one. Difference is 1 over x is not defined at 0. Is not defined at 0. Rather, it has an asymptote, while x is defined at 0. Right? Pretty simple. Let's move on to c, where we have so much similarities. So, absolute value of x and x squared. So now this is when we can finally talk about something that is not a domain. Let's talk about symmetry. Let's talk about symmetry. Yeah. So both functions are even functions, right? Even functions meaning that they are the same. They're reflected across. So when you have one side of the y-axis, they're symmetric across the y-axis. So when you have the left side of the y-axis, you trace it perfectly on the right side, and you will get the entire function. So both functions are even functions, right? And are symmetric about the y-axis. Now, what are the differences? Well, let's talk about shape. So absolute value function has a strict V shape, while a quadratic function is in the shape of a parabola. It sounds like so obvious. Let's go ahead and get on to 5D, which is our last part of this funs. So 2 to the power of x and just regular x. So what are the commonest? Well, we talked about 2 to the power of x before. They're monotonic and they're always increasing. And we also know that x is always increasing. It's positive, right? So they are both monotonic, meaning that they only increase or they only decrease. They only have one motion. Monotonic, and they always increase. Now, what's the distinguishing part? So 2 of x can actually be negative. Sorry, 2 of x is an exponential function and can never be negative. Meanwhile, x can be negative and positive. Okay, let's go ahead and get to question number 6, which is asking us about the intervals of increase and decrease and the symmetry and the domain of range of each function. Let's go ahead and do that. So 6a. So what does 6a have? It's f of x equals to 3x, so we'll have a positive slope of 3. So positive slope of 3. And as we just discussed in the very last question, it's monotonic. So it's increasing. So increasing from negative infinity to positive infinity. So it increases over in its entire domain. Oh, infinite instead of infinity. Okay, there we have infinity now. And no decreasing time. No decreasing part. And then the symmetry is obviously it's an odd function, right? And because it's odd, it's not translated anywhere. It doesn't move anywhere. It doesn't move up, move down, move left, move right. So it's symmetric about the origin, and it is odd. And our range is, our domain is all real, x is all real numbers. That's pretty obvious. It's a linear function. X is all real numbers, and because it's a linear function, y is also all real numbers. Range, y is all real numbers. Okay, x squared plus 2. I will be skipping this question because it is very simple, and I just want to talk about the increasing exponential function. So let's go ahead and talk about c. You guys should be able to do 6b. There's an answer at the back of your textbook, so you should be able to check. Let's go ahead and talk about 6c. So because 60, it's exponential function, and exponential functions are also increasing function. They're monotonic, as we discussed in 5D. So it increasing from negative infinity to positive infinity with no intervals of decrease. And because there is a translation, and because of the function characteristic itself, the function is not symmetric at all. What else do we need to discuss? Let's discuss the domain. So the domain, as we can tell, an exponential function comes from here, and then it goes all the way up. It goes slow increase, and then finally it goes huge increase. So domain is x is all real numbers, because no matter what you put into x, it will always give you a value. Even if you put a huge negative number, huge positive number, it doesn't matter. No matter what you put in there, there's always gonna give you a y value as a result. So domain is x is all real numbers. Now the range is the hard part. So what is the range? Since we know 2 of x is always greater than 0, right? The parent function itself here is 2 of x. That's always greater than 0, because exponential functions are never negative. Because 2 of x is always greater than 0, that means, and 2 of x, so let's write some math. Since 2 to the power of x is always greater than 0, that means if we minus 1 on both sides, 2x minus 1 is always greater than negative 1. We're very simple, so we have always greater than negative 1. So we bounded our function. Now we can talk about the range. So if we bounded our function is already, we can talk about y is all real numbers. Such that y is greater than negative 1. Okay, my space is bugging out, but that's okay. So that y is greater than negative 1. Yep. Now let's talk about finally 1.4. State the parent function, and then so I will not be graphing any of these, and I'll only be doing A and C. And so let's go ahead and do some of this. So 7. So the parent function right here is pretty obvious. 1 equals the absolute value of x, right? The transformation here is very simple as well. So we only have x plus 1 inside of the bracket. So that means x is moving 1 unit to the left. So shift 1 unit to the left. Yeah, I don't know why my space bar. Oh, it does work. I just didn't press it hard enough. Shift 1 unit to the left. And C. So we're skipping B. And you should be able to graph this really quick. So B, it might look frightening at the start, but it really doesn't. So negative 2 sine 3x plus 1. So we have pretty much everything here. So the parent function right here is y equals sine x. Hopefully you can tell that. So we want to talk about the hardest one. Let's talk about 3x. So a horizontal compression. That means we changed our period. Horizontal compression by a factor of 1 over 3, meaning our period becomes 120 degrees. 120 degrees, right? And because we have this negative 2, so we will have a reflection about the x-axis, while a vertical stretch by a factor of 2. Factor of 2. Perfect. And then now we're finally on to the very easy stuff. So plus 1, that means shift 1 unit up. Shift 1 unit up. And you should be able to graph this as well. It's pretty simple. If you have any of these questions you feel hard, just leave me a comment or send me an email, and I'll do a video taking up all of the hard stuff that you guys have requested once you guys have requested enough questions. Anyways, let's go ahead and move on to question number 8. So the graph of y equals to x squared is horizontally stretched by a factor of 2, reflected in the x-axis, and shifted 3 units down. Find the equation that results from the transformation, and you guys will be graphing it for me. Let's go ahead and do that. So the graph of y equals x squared, we're really familiar with this. It's just a simple quadratic function. So first, Let's do horizontally stretched by a factor of 2. So what does that mean? Horizontally stretched by a factor of 2, meaning that we will have 1 over 2 as our k value. So let's go ahead and do our AK, PQ, or stuff like that. Y equals to A f of x, f of k, x minus p. What am I doing? P, x minus p square bracket plus q. So I shouldn't have that, plus q. So this is our entire parent function. Let's talk about all of these PQ values by its own. So k value, because we have a horizontal stretch by a factor of 2, that means we have 1 over 2 in here, because we want to do 1 over 1 over 2, which gives us 1 over 2. So reflect it in the x-axis, but there's no vertical stretch. That means a is negative. A is just negative 1 simply. And then we have 3 units down, but we don't have any horizontal translation, so p is just 0. And then finally, q, since we're moving 3 units down, is negative 3. So q equals to negative 3. So let's plug everything we have in here while also plugging in our function. So we should have negative 1 over 2 x squared. Sorry, this should be in here. So x squared over 2. Finally, we will have negative 3. Sorry, this shouldn't be here. This should be on the outside, because the k value is inside, right? This is f of x. So negative x over 2 to this squared minus 3. So we have that, and you should be able to graph this. Let me give you the vertex, because we don't have any horizontal translation, so our vertex is also still on the y-axis. So vertex is 0, 3. 0, 0, sorry, negative 3. Okay, let's go ahead and do 9. I'll be doing A, C, and E, so you guys can take B, D, F. So 2, 1 is a point on the graph y equals to f of x. Find the corresponding point on the graph for each of the following functions. Okay, let's go ahead. This is getting really interesting. This is a style of question that you might be facing on your assessments, because these are kind of confusing. So first, let's go ahead and do 1. So y equals to negative f of negative x. So negative x basically reflects the point across the y-axis, right? Across the y-axis. So how do you reflect across the y-axis? Well, 2, 1 will become negative 2 and 1, right? We reflected out of the, so negative x means that 2, 1 becomes negative 2, and 1. And negative f of negative x, what does this mean? This means that we will have another outside negative that crosses the x-axis. So we're gonna, not only are we reflecting about the y-axis, we're also reflecting about the x-axis. So when we have this and we reflect this point across the x-axis, what do we get? We'll get negative 2 and negative 1. So negative 2 and negative 1. And because we have negative 2 and negative 1, and finally we will have to add 2, so we're shifting 2 units up. And because we shift 2 units up, it only affects the y coordinate. So negative 1 plus 2 will get us back plus 2. Or plus 2 right here, we can just understand it as plus 0, 2. That means we will have, finally, y is equal to negative 2 and 1. Because only our y value is influenced. The x, this is outside the bracket, right? This is very interesting. These type of questions are likely what you're going to get on your assessment. So then do C. F of x minus 2 plus 2. So finally we have something that's inside of the bracket. Let's see what we can do here. So first, let's set the input equals to 2. So when we have the input equal to 2, so our input is 2, 1. So when we have our input of x minus 2 equals to 2, then we'll have x equal to 4, right? X minus 2 equal to 2. Because 2 is our inputted x value. So x is equal to 4. And now the outside value, because the outside value doesn't get influenced by this, rather get influenced by the plus 2. So y is equal to 1 plus 2, which is equal to 3. So because we have x equal to 4 and y equal to 3, our point is 4, 3. Pretty straightforward, and I know you're enjoying this. And finally, we'll have one last question that I'll be doing for you guys. So 1 minus f y minus x. Okay, so let's do it. Let's do this. So let's set the, again, we're doing the same strategy. Set the input equal to 2 because that's what we're really inputting. So x equal to 2. So 1 minus x equal to 2. So x is going to be equal to negative x is equal to 2 minus 1, which is positive 1. Negative x equals to 1, so positive x equals to negative 1. X equals to negative 1, right? And then our y value is going to be equal to the output. So our y value is going to be equal to, y is equal to 1 over, 1 minus f of 2, right? And then 1 minus f of 2 is just 1, so 1 minus 1 is 0. So we will have our setup point being negative 1 and 0. Okay, that is all that we will be covering in our part 1 of our unit 1 review. So we will have all of these questions done. And in the next video, we will be doing everything else that we have on this side. So everything that we've done in the second part of this unit, we'll have our functions a little bit more, and then let's talk about some arithmetics. Yeah, these are some 3 lessons review. Okay, you guys can take a break now, and I hope you guys enjoy the lesson. Have a great day.